Good morning. I welcome you all on the new video on this page of Electrical Engineering, Sakkar IBA University. So my name is Hamza Safdar. I am going to represent myself on behalf of my whole group. My group include Mr. Hamza Khan and Muhammad Qasim as well. And we have done a particular FIP named Microwave Weeds to Enhance Agriculture under the supervision of Dr. Muhammad Yamin Sindhu. So here's the table of content. Firstly, I'll discuss some introduction, then we'll go through some under motivation. What was the motivation behind my FIP? What was the problem statement? What was the literature review? What was our aims and objectives? What methodology we followed? What was the results and conclusion? And future recommendations as well. So basically, human health is directly linked to the quality of food and the environment they live in. If the food is healthy and an environment is safe, they will live a long and healthy life. But what if they get a food that is less nutrition, that has less nutrition and has chemicals in it? Basically, in crops there are weeds. Weeds means unwanted plants like porcelain, nutgrass, etc. These plants cause hindrance in our desired crop growth. So in order to remove those plants, we basically goes towards two methods. First one is manual picking, the other one is chemical. For the chemical sake, there has a lot of negative impacts. So due to those negative impacts, the environment as well as the nutrition get affected, and basically the nutrition less crop is produced. So basically, here's the introduction of this. Weeds in crops are managed using chemical herbicides or labor intensive manual weeding. Manual weeding is so much costly on large scale, while chemical herbicides have negative impact on crops or the environment and human health as well. Weeds are increasingly developing resistance to chemical herbicides over time. It means that with respect to time, the if we further we more we spray the basically chemical, weeds are not going to be affected. So there was a need to find an alternative for this for this method, basically for these weeds. So in order to address this challenge, we have developed a prototype for treating weeds using microwave technology. So what was our motivation? Our motivation was to ensure the production of healthy and uncontaminated food, to provide consumer with safe nutrition, to minimize the use of chemicals in agriculture and environment, to enhance crop productivity by efficient managing weed competition, and to addressing herbicide resistant weeds by providing an alternative method that weeds cannot adopt easily. And also this is a new market opportunity. Till now Pakistan has not done any kind of work in this particular field. So what was the problem statement? Our problem statement was basically weed infestation in agriculture poses a significant challenge. Traditional management method, labor intensive method, manual weeding were so much costly as I discussed before, and chemical herbicides cause soil and water contamination, harms non-targeted species, poses health risk to farm workers and consumers, and also basically it was harmful for the nutrition because chemical method have some kind of negative or harmful nutrients like glyphosate and phosphate. So addressing these issues is crucial for achieving sustainable goals SDG 13 and SDG 15. So our FIP is also related to those particular SDGs as well. So this is our literature review. These were some of the literature review we studied in order to perform our FIP. Basically, these literature review was mainly related to the body and our supervisor Muhammad Yamin Sindhu. Basically, body has done a lot of work on the hardware, while our FIP, the other research paper help us in working on the software on HFSS software. So these are the few basically research paper titles, and these as well, like Muhammad Yamin Sindhu, he's our supervisor. This basically these kind of basically research paper help us in understanding the working principle of microstrips or the waveguides that we use in our FIP, how basically these electromagnetic waves affect that particular weed, what will the working mechanism. So that these are all literature reviews for that. So and same goes for that, the electric loss and the electric permittivity also affecting. So What was our aims and objective? Our aim was to develop a field scale prototype that efficiently control weed in vegetable farms using microwave technology to minimize crop damage and reduce the need of labor intensive and chemical methods. To ensure the solution is cost effective, environment friendly, safe, and easy for small to medium sized farmers to implement and maintain. So objectives include prototype design, dialectic characterization that I'm going to discuss about, and field testing and power dividing assignment. So, what methodology did we follow? First of all, basically, we conduct certain type of surveys on particular type of crops like onion, okra, tomato, etc., to identify that what kind of weeds mostly grows in these kind of crop. And in these type of, and we came to know that after the particular surveys that there are four type of weeds that mostly grows in these kind of crops. It includes porcelain, nutgrass, green amaranth, and Egyptian grass. So basically, we collect weeds, basically weed seeds from basically identified for the our say experiments, weed seed and plant treatment experiments. What we have done in it, basically, we conduct separate experiments on each weeds. On each, basically, we have worked on seeds, stem, and leaves on three different scales so that we can eliminate the unwanted weed throughout the whole, like seed, stem, leaf, all of it. So basically, we prepare multiple weeds plant pots and treat them with different incident power level, different resident times, and at least two different radiation antenna type. So we recorded energy radiated, absorbed, reflected. We recorded the whole thing. The Let's move on further. What was the weed seed treatment? Basically, we prepare a sample by mixing the weed seed with soil and treat each individual sample individually. They this process have three type of samples. What was the soil condition, what was the incident power variation, and what was the residence time, the time of exposure to that particular electromagnetic fields. So basically we also recorded these type of energy, these readings. So here was a prototype design. We basically designed a prototype, a field scale V treatment device with multiple open-ended radiator in order to cover that particular area to affect the unwanted plants or weeds. To ensure energy is not coupled between applicator for safety. Use electromagnetic simulator tools to optimize physical design and prevent directed energy towards human and animals so that they might not gonna be get affected by the microwave radiations, because as we all know that microwave radiation are so much harmful for animals or any kind of species that came in contact with it. So simulate various radiator geometries in 3D electromagnetic simulator software like HFSS and ADS for dielectric characterization. We also done some field trials, pre-plantation weed seed killing. Basically, our FIP is mainly related to that pre-plantation process. So before plantation or before digging the basically soil for basically to sorry basically let's start again. Basically for this is also here is the field trial, pre-plantation weed seedling killing. Basically select a sizable area for cultivated land subdivided into small patches. I will go discuss about what was the area of that particular patches. We have done basically two under two type of patches, and they have different areas. So keep one patch untreated and treat the rest with optimal power levels for three different resident times and two different soil conditions at variable soil moistures. Observe germination or growth of weed plant over definite period of time to evaluate treatment expenses. So here's basically a very important thing to say that basically whenever we treat a particular material that is our test living material under test and we provide it low power for high time, it will grow. The productivity will increase, it will get power. But when we apply a high power for a short particular duration, anything will gonna be burst up, everything will gonna be destroyed or eliminated. So this is the main working principle that we followed. What was the methodology? Here's a basically diagram for that. We have a power supply at the start, and a generator, which is basically our magnetron, which is used to generate microwave frequency. Then we have a isolator to isolate the electromagnetic waves. which are basically reflect back. With there's a bidirectional coupler which is used to basically normally we have a digital power meter connected with it as well. Then the waveguide to guide the basically these electromagnetic waves towards the load, which is basically our soil. So the three sub tuner, waveguide applicator, and directional coupler, and we are know familiar with it. So there's another main portion of our FIB of this project is the electric characterization. The electric characterization basically is a property which is used to determine how a material interacts with the electric and magnetic fields, particularly at microwave frequencies. So this was a hardware that we designed for this particular task. There's a vector network analyzer that is connected to the input and output. The power is in the power in is input is here and the output is here. We just insert gave the input power, and the power just goes to this particular area. Here's our basically sample of unwanted seeds to check out at what frequency or at what electromagnetic field magnetic fields what will be their particular response. So we get the particular response of our this these kind of for that kind of seeds, and some energy will be absorbed and some energy remaining energy will just basically went to the output area. So we have done this type of particular work for all including seeds, stem, leaves, for all type of basically unwanted weeds. So basically the main understanding thing is what. Let's move toward this graph to understand what is the need of dielectric characterization. Basically, as you can see, there are three particular curves in this graph. One is for empty sample, which is basically shown by red cursor with red graph, and the other one is porcelain leaf, which is shown by the blue graph, and the other one is porcelain stem, which is basically shown with the pink one. So as you can see, when there is an empty sample, there is no sample. It means that the power, initial power that just entered, the maximum power without any loss is just transferred to the output. But when there is a sample, like when there is, as you can see, is there's a leaf. When there is a leaf, most of the power will be absorbed by the leaf, and as you can see, like here is almost like minus 13 dB. There will be loss of minus 13 dB, and particular frequency of you can say 2.87 basically gigahertz. So at this particular frequency we get the what will be the relative permittivity and the electric loss tangent or for this one, so that we can treat them easily. The main basically the main thing we were interested in that particular peak. As you can see here that this is the peak where basically we are interested in. This is the measured one, like the actual graph of that seed, and this blue one is the basically that we have basically solved in HFS software by changing the relative permittivity and relative loss tangent values in order to get this desired response. And at a particular frequency, we have basically mentioned in our thesis that at particular these frequencies and relative permittivity and relative loss tangent, we are going to get this frequency and this basically loss experimental loss in dB. So this is the for Egyptian grass leaf and stem. This is basically graph for that. This graph is for nut grass and porcelain leaf. This basically, now let's move towards this lab scale prototype. Basically, as we are familiar with that microwave oven also have a capability to produce microwave frequencies. So basically at the start we will just use that microwave oven as a source of energy. We use it for lab scale testing, and let's as you can clearly see, there's a microwave power meter to check the what was the forward power and what was the power that was reflected from the load, which is basically solar. So this is basically a field prototype that we have designed. Here's the power supply is connected to the basically magnetron, and basically magnetron basically generate the microwave frequencies, which is basically guided toward the soil with that 5 gate waveguide. Okay. So here's the field testing. Now here we have used basically oven. We have tested this particular field test on basically grass by using the oven horn antenna. The basically source is basically that is power supply is oven, and the again and the forward horn antenna is basically the same. And we can the resident time is 3 minutes, and you can see the results. There is basically a minimal result. The oven have a power of 900 watt. So let's move towards the another. This first magnetron, as you can see, the resident time is the same, and the basically the affected area affected is much higher than as compared to the oven. Here's the second magnetron. Basically, we worked on two magnetron in order to check if there is one faulty or there's any kind of other thing, but both are working fine. So here's the second magnetron. As you can clearly see, the working principle is fine. The working is fine, and they are just eliminating the unwanted plants. So here's the basically area and patches of this basically results in discussion. The sources are first magnetron, second magnetron, and O1. And what is the size of basically patch size as 14 cross 15 and 12 cross 14 for each. And basically these are the basically areas as mentioned. So the main work till now, basically this is the main work till now. No have done such kind of work for this basically product. We have designed a power divider. What will a power divider do? Power divider will simply divide the input power basically, which will enter from the port 1, and divide it equally to the 33% to port 3, 33% to port 4, 33% to port this one, so that in all power is divided equally. And this is very helpful for the area which have contour lines or which have ridges, so that the focus is on the sides and as well as on the ground, and unwanted weeds will be eliminated properly. So here is basically the dimensions mentioned here. Dimensions, like you can see, these are the certain dimensions which will gonna help you out to design this particular waveguide antenna as well. If you are interested in, you can just zoom in and you can just watch that particular dimensions. So here's the result. As per the standards, it is clearly seen that the reflection through that particular antenna should be less than minus 20 dB. So as you can see, this particular red line which have reflected power, it minus 26 dB, which is well accepted. And if we see the output power, the output power, which is basically is minus 4.81, which is means that 33% of the power is equally divided on all three slots. So what was the conclusion? We have basically microwave technology offers an effective alternative for manual and chemical weed control. Our optimized prototype control weeds in vegetable farm with minimal crop damage, sustainable for both pre-plantation and post-plantation use. Basically, field scale trials confirm the efficiency of microwave weed control, efficiently reducing weed growth with minimal environmental impact. This method basically addresses herbicide resistance, contaminations, and health risks, supporting several SDGs for safe and sustainable agriculture. This technology promises a cost-effective, user-friendly solution for small and medium-sized farmers. Further refinement and large-scale implementation can enhance crop yields, promote sustainable basically agriculture, and ensure safe environment. What was basically our future recommendation? We want to pursue carry on this work future with the power divider. We have fabricated basically we have designed this one, but yet we have the test. We want to test that power divider on the fields. We want to embed AI with this particular project so that it detect the basic unwanted weed, and then it will operate according to that. And furthermore, basically there is another perspective of can be other perspective of AI as well. So another further recommendation is that we want to communication with it remotely, and to extend the data like we have just done it for samples, and we want to extend the data so that it will be more effective. So we want to get the power input power from the solar, so that we can install a solar plate or any other basically method to get the power. So here were the references. There are a few of the references which help us a lot in this project. Here are that. And yes, these are all of them. Thank you so much. If you like the video, please follow us on this WCBU and WCBU on YouTube and Facebook as well. Thank you so much. And if you have any question, you can contact us on our email address, which is given at the start of this video. Thank you so much.